What is the common chord? By definition, it is the line segment formed by joining the point of intersection of two circles. So let's say this is circle 1, let's say this is circle 2, and they intersect at point P and Q. So the line joining, straight line joining P and Q is a chord for circle 1 as well as circle 2. That is the only possible common chord. That is the only chord common to both circles. Yeah. Now, what we know about a common chord is that this line O1, O2, the line joining the center, is the perpendicular bisector, which means it passes through the midpoint of PQ, which means PX is equal to XQ if X is the point of intersection. And this line O1, O2 is perpendicular to PQ. So PQ is perpendicular to O1, O2. O1 is the center of circle 1, O2 the center of circle 2. And of course, O1, O2 is a perpendicular bisector. Is this something you remember? Is this clear? Yes. Okay. O1x is not equal to O2x. It's good that you asked. No way. O1x is not equal to O2x. They are equal only if the radius of the circles are equal. Here the radius of circle 1, so R1 here is greater than R2. 1 is the bigger circle, 2 is a smaller circle. O1x will not be equal to O2x. Yes. Okay. So what that means is PQ is not the perpendicular bisector of O1, O2. It's the other way around. Okay. Sorry. Let's go back to our recap. We must have also seen this. Tangents from external point are equal. Just cover that. We did not see alternate segment theorem, which we'll see right away. What is the alternate segment theorem? It's a bit complex and it's very interesting. Say I have this tangent. Yeah. Let me mark it. Let's say this is point P. So PA is tangent to my circle, and from the point of contact A, there is a chord AB. A chord of the circle is AB, and the chord AB makes an angle theta with the PA. And the theta it makes is in the minor arc AB. So we had studied that there is a minor arc, this arc AB, and of course there is a major arc AB, the longer one. So if the theta is made as a part of the minor arc or towards the minor arc, then theta will also be reflected by AB on the major arc. So if this angle is theta here, the chord or the minor arc AB will subtend theta on the circumference of the major arc. So all angles, we've already covered this. If this is theta, then all angles subtended by AB will be there. This will also be theta. Any other angle that you may think of. This will also be theta, and so on and so forth. Yes, is this cool? Is this good? This also means, guys, let me go back to my board. Now I've taken an acute angle. Let me take an obtuse angle, just to make it absolutely clear. Yeah. Oops. Say this is I don't know. Let's say this is BA. Let's use the same labels. This is BA. PAT is tangent to the circle. AB is a chord. If this angle is alpha, clearly greater than 90 degree here, then alpha will again be reflected in the other portion. So the angle that tangent alpha is making is in this portion of AB, in the major segment AB. So alpha will be reflected in the minor arc. This will be alpha, or all other angles subtended by AB on the minor portion, on this portion, will be alpha. Is this clear? Okay, that is very good. Cool. Last but not the least, cyclic quadrilaterals. Now, what are cyclic quadrilaterals? Quadrilaterals whose all four vertices, whose all four vertices lie on the circumference. When all four vertices of a quadrilateral, so A, B, C, D here, all lie on the circumference of a circle. You can also see this as a quadrilateral that has a circle circumscribing the quadrilateral. So a circle is circumscribing the quadrilateral. It has to be a cyclic quadrilateral. And for a cyclic quadrilateral, sum of opposite angles is 180. Opposite angles are supplementary. So angle A plus angle C is 180, which means if this angle is theta, this has got to be 180 minus theta. If this angle is alpha, this has got to be 180 minus alpha. Sorry. Yeah. Now, is there any relation between theta and alpha? Nope. There is no relation between angle A and angle B in general, or angle A and angle D. There is no relation in general between adjacent angles. But there is clearly a relation between opposite angles. Both, for both pairs, the angles are supplementary. Okay, very good. Well, this also means, just so that this becomes clear, if I were to now extend AD, if I were to extend AD, how much would this angle be? If angle B was alpha, how much would this angle, exterior angle of D be? It will also be equal to alpha. Absolutely. So exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. That is true for any exterior angle. I extend side CD or DC here. What do I get here? This has to be theta equal to opposite interior angle. Okay, very good. Very good, very good. Mensuration. We are going to cover the formula uh, of perimeters and areas and volumes and surface areas for 2D and 3D figures. I'll just take you through this once. Feel free to take snapshots, but we have covered most of this already. So you know for a rectangle, the perimeter is twice of A plus B, and the area is A into B or L into B. You can you can replace A with L here. Similarly, for a square, perimeter is 4A, area is A square. Triangle, of course, perimeter is A plus B plus C, which is twice the semi-perimeter. And you've seen the area, these two formulae, you've seen three more. You know for a right triangle, area is half into the product of perpendicular sides, and of course the perimeter is the same. I'm not even going to talk about like equilateral triangle or isosceles. Parallelogram we've seen already. Opposite sides are equal and parallel, so perimeter is twice of A plus B, and B being the two sides. And of course, area is A base into height. For a rhombus of side A, perimeter 4A again. Area half into product of diagonals, half into diagonal 1 to diagonal 2. For a trapezium, it's you know everything here. Area is half into sum of parallel sides into the height. You know about a circle. This is relevant if you not very difficult but relevant. For a ring sort of portion, there will be many questions asked here on this. For a ring kind of 2D figure, the shaded area is clearly pi r square, the bigger circle, minus pi small r square, the inner circle, which becomes equal to pi into capital R square minus small r square. Yes, we've already seen the area of a sector. Let me know if you have any problems here. Let me know if you have any problems here. We've covered almost all of all this. Okay, very good. No response. What about this? This is important. Can you guys see even up to? Can you guys see up to sphere in terms of the screen? Can you see up to sphere? Okay, cool. Yeah. So let's talk about a right circular cylinder. So when you hear the term right circular cone or right circular cylinder, it essentially means a right circular cylinder is one in which the base or the top of the cylinder. This is what a cylinder looks like. Imagine a Fanta or a Coca-Cola can. That is the cylindrical shape, of course. So you have a curved surface. This is the curved surface, and of course you have the base and the top area that are flat. This is the base. A right circular cone is essentially a cone in which this axis, the line joining the center of the two circles, when this is perpendicular to the base. So the height is like this, and if I were to mark out the surface of the base, they are perpendicular to each other. That is what a right circular cylinder is, and the same holds for a right circular cone. So the axis of the cone is perpendicular to the base. That's a right circular cone. Yeah. Okay. There's my file. So for a right circular cylinder, curved area is 2 pi r h, and total surface area is curved surface area plus area of base and area of top. The total surface area is equal to curved surface area. Let me say curved surface area plus area of top, which is pi r square, plus area of base. Yeah, and volume is pi r square h. Now, what I want to tell you about all these figures about a right circular cylinder, there is a general formula for curved surface area and volume for a right circular cylinder, and a cube and a cuboid. Not here. I don't have a cube and cuboid here. What a shame. Which is okay. So a general area for a solid whose dimensions are not decreasing. So like a cone, a cone has its area of cross section constantly decreasing up to 0. So at the top of the cone, the area of the cross section is 0. At the bottom, the area is of course pi r square. So figures where the area of cross section is constant, like a cuboid or a cube or even a cylinder, for all of them. So this I've drawn this is a cube. Let me also draw a cuboid. A cuboid just does not have equal dimensions. Let's say it's something like this. Yeah. So yeah, for cube, cuboid, or for cylinder, the general area of the lateral or the curved surface area. Yeah, let's use the term lateral surface area. So the lateral surface area is the perpendicular area. So for a cube, it would include this side plus area of this side plus this side plus the one at the back, and the plus the one in the side, and the same for a cube. And for, of course, a cylinder, lateral surface area is a curved surface, the area of the curved surface. This is always equal to the perimeter of base. Is equal to the perimeter of base into height. It is really simple. All lateral surface areas are like this, except of course for cone or for sphere. And for and the volume is their volume is area of base into height. Now, why is this? Let's just try to understand this. Why is this so? And let's also try to understand our figures a bit, our cylinders and cubes and cuboids a bit. Now, what is a cylinder like? Say I have this cylinder. Let's say this is a hollow cylinder. I think it makes it easier to understand. Let's say this is a hollow cylinder. If I would just give it a cut here and expand it, then this would look something like a rectangle. In fact, not something like, it would look exactly like a rectangle. Or in fact, you can imagine this. You can imagine a rectangular sheet. Imagine your copy, a page of your copy, and you try to fold it. You know what? I can show it to you right now. Just a second. I think that would make it easier. This is a rectangle, clearly. Yeah. Now, if I were to fold it along the length, it would become a cylinder. This is a cylinder now. Yeah. You get a circular base, and the height is, this is the height. So what is happening essentially is, to the rectangle, or if I were to, if I were to now unfold it, what happens is this base, the base circumference, this becomes this side. This is essentially 2 pi r, where r is the radius of this circle, or the base circle, whichever circle you want to take. Both are the same. And the height obviously remains the same. Yeah? So the curved surface area essentially becomes 2 pi r into h. Yeah? Becomes 2 pi r into h, and that is what I mean when I say that the area, the curved surface area or the lateral surface area is perimeter of base 2 pi r here into height. Is this clear? This is true for all figures, cube and cuboid as well. And what is volume? What is the volume? The volume is essentially seen as, think of stacks of pi r square. Think of stacks of circles. Circles like this being stacked one on the other, one on the other, one on the other, and they keep on stacking up. Think of these as circles being stacked up. To reach a certain height. So the volume becomes pi r square times height, area of base times height, and for a cylinder it becomes pi r square into h. Yeah, is this clear? Okay. Okay, very good, cool. So let's have a look at these formulae again. Curved surface area 2 pi r circumference or perimeter of base into height, volume pi r square into h, total surface area, curved or lateral surface area. Let's use the term lateral surface area. Lateral surface area plus area of base plus area of top. If the cylinder is a hollow one, if it has neither a base nor a top, then total surface area becomes lateral surface area. Here, the formula that has been given is clearly assuming that there is a top and a base, or this is a solid cylinder. So yeah, so in that case, it would have been 2 pi rh plus 2 pi r square, which is what this represents. 2 pi rh plus 2 pi r square for the base, pi r square for the top. Okay, cool. Right circular cone. Lateral surface area, the curved surface area is pi rl. L is the slant height given here. And total surface area is, of course, pi rl plus pi r square. Pi rl plus pi r square, pi rl the lateral surface area, pi r square the base area. Volume is 1 by 3 pi r square h. And the way r, h, and l relate to is this relation, Pythagoras theorem. L square is equal to h square plus r square. It's really simple. And thus L is under root of h square plus r square. Yeah. L is the slant height, known as the slant height. Okay, cool. Sphere, total surface area is 4 pi r square. Volume is 4 by 3 pi r cube. A hollow sphere, assuming it has an outer and an inner radius, a shell essentially. This is a shell. So its outer area remains 4 pi r square actually. 4 pi capital R square, if capital R is the outer square. And of course, the volume of the shell becomes 4 pi r cube minus r cube. So you take out the volume of the hollow part and you get, so for a hemisphere, volume becomes half, whereas curved surface area also becomes half. My total surface area of a sphere was 4 pi r square. For a hemisphere, it's 2 pi r square. Total surface area is 2 pi r square plus pi r square for this surface, for the base, for the flat surface, that is. So total surface area 3 pi r square. Same for a hollow hemisphere. Now what is interesting is, and this is important also, what happens when you try to mold a sector into a cone. Again, let me show you using my sheet of paper which is gone with the wings. Let's see. I have cut this out. Yeah, it's a sector of angle theta. It is subtending theta. So imagine this being a large circle. I've cut out a sector of angle theta. If I were to now join this side and this side, join the two sides in this manner. So what I've done is I've joined the two radius, the end radius. And formed a right circular cone. It's not a perfect cone, but this is what it will look like. Yeah, this, as I said, it's not coming out great, but yeah, it's this is how it will look like. And what essentially this means is your arc, the arc at the bottom, the length of the arc becomes the circumference of your cone. So what I want to say here is, you can, as you can see in the diagram, you can make from a sector of angle theta, you can make it into a cone by changing this arc into 2 pi r into the circumference of the cone by taking this r, the radius of the sector, to be the slant height, or by assuming that the curved surface area, the total area of the sector rather, the total area of the sector, the shaded portion, this portion, becomes the curved surface area. The curved surface area of the cone. So the curved surface area of the cone is equal to the area of the sector. The radius of the sector is equal to the slant height of the cone. And the length of the sector, the length of this arc of the sector rather, becomes the base circumference of the cone. And if you were to just, if you were to use them, so radius of sector is r, this becomes equal to slant height of the cone. Length of the sector is theta by 360 into 2 pi capital R, becomes base circumference of the cone, which I will take as 2 pi small r. So now I have everything. I have small r, which is theta by 360 into capital R. I have L, which is already equal to capital R, which essentially means L, which is equal to, as we had discussed, h square plus r square ka under root. The slant height is under root of h square plus r square. What will be the angle of the cone? 90 degree. So this angle you don't need to really care about. So here, if this is the cone I get finally with a slant height L, with radius r, let this be r, and with height h, yeah, then this is the semi-vertical angle. You can call it theta, and we generally take sine theta. So we generally take sine theta as semi-vertical is r by, clearly sine theta is the side opposite by hypotenuse, it's r by L. We haven't talked about trigonometry, so I didn't talk about this. This is not important. You don't really need this. Not. There will be only one unique. Of course not. Of course there won't be. There, r by L is a ratio. There can be many cones using the same theta. Theta is just an angle. You can have a small cone like this. You multiply you multiply all dimensions by 10 and you still get the same theta. So imagine a bigger cone with 10 times slant height, 10 times the radius, and 10 times the height. Will it have the same semi-vertical angle? Yes, it will. Okay, cool. Yeah, so I hope this is good. Just have a look at this formula. Volume of water that flows out through a pipe is area of cross section into speed into time. What does this mean? I'll throw a question at you and yeah, probably ask you to swim in the deep end straight away. We'll do a question on this and basic conversions that you should probably know. The most important of which is probably this: 1 meter cube is equal to 1,000 liters, and 1,000 centimeter cube is equal to 1 liter. These are the two important ones. I suspect you would not need any other. Okay. Okay, I hope you guys don't have any. Okay, this is. We'll come back to this. Let me just throw a couple of questions at you. Yeah. Do you mind solving question 3, this question? Please try question 3. Find the radius of the height of a cone formed from a sector of a circle of theta equal to 120 and radius equal to 10 units. What will be the radius and height of a cone formed from a sector of a circle whose theta is 120 and whose radius of the sector is 10 units? I'd also want you to try question 4. Please try question 3 and question 4. And even question 6. Very simple question. 3 simple questions. Please try. Okay. Many answers. Some correct, some not. We'll discuss this if need be. Please switch your attention to question number 4. We'll discuss the answers, don't worry, guys. It is 20 root 2 by 3 indeed, which is root 800 by 3. So Nitika and Lakshya have got it right. Vinay, your answer is not correct. Anubhav, yours is correct. Krishna, you should check your height, please. Your radius is correct. Fourth is 3080. Yes. Yeah. Lakshya's got it right. You can use pi. See, whenever you find multiples of 22, just use pi. Sorry, multiples of 7 in either the radius or the height. Just use 22 by 7. Yeah. Use pi to be 22 by 7. Okay, 6 is simple. I don't think you'll take time. 6 is the length of the rope will be 2 pi r in question number 6. So you can calculate 6 quickly and maybe we'll move ahead. Yes, it will be 14. Diameter will be 14. Very good. Excellent. Lakshya, it's asked for, it's asked for diameter. Excellent, guys. Excellent. Good. We'll discuss this, but I want you to try a couple of other questions. Yes, here they are. So please try Question number 10. Just try question number 10. So maybe what I can recommend. Sorry, in question 10, um, change the seconds to minute. 20 meter per minute. Change this to per minute. Sorry. Let's make this a realistic question. Otherwise, it's going to give you a huge value. Please change this into 20 meter per minute. And I hope you remember the conversion between a millimeter, a centimeter, and a meter. 1 meter is 100 centimeter, and 1 centimeter is equal to 10 millimeter. Zero point 0.0154 is the right answer. 0.0154 meter cube is the right answer. Absolutely. Okay, I guess let's discuss, and we'll do more questions, especially some more on circles. I definitely want to do more questions on circles. So, any problems with question 10, guys? Any problems with question 10? I will explain. Okay, where's the sheet gone? Sorry. Yeah. So what volume of water flows from a small cylindrical pipe of dia 14 millimeter in 5 minutes, flowing at 20 meter per minute? So what can you expect from the volume? So think of it like this. There's this small cylindrical pipe. Yeah. It has a certain cross section. Radius has been given to be or dia. Was it dia or was that radius? Or dia 14 millimeter. Okay, cool. Yeah, dia is 14 millimeter, radius is 7 millimeter. So when it says it flows 20 meters in per minute, it means that the amount of water that is going to come, the essential assumption is that water will, full of the pipe will throw water that is sort of complete. It completes the cross section. So the whole cross section will sort of spit water, and in 1 minute. So let's say this is 20 meters. In 1 minute, the water that you'll have is this will essentially be per minute a cylinder like this. So the volume water thrown out in a minute will be a cylinder of height 20 meter. That is not working. A cylinder of height 20 meter, and of course, as we have seen, of base radius 7 millimeter. This was in 1 minute. So you can calculate this for 5 minutes. So for 5 minutes, the water that will be thrown out will be, something like this. So 20 meter into 5. Assume that, if it's traveling 20 meters in 1 minute, it will, of course, in 5 minutes travel 100 meters. So your volume essentially becomes volume of um, volume of a cylinder of height 100 meters. Volume of a cylinder is pi r square h. So pi 22 by 7 r square. Now this is where you need to be careful. R square is 7 millimeter. Let me convert this to centimeter. So this is 7 millimeter is 7 by 10 centimeters. So 7 by 10 ka whole square into h, which was 100 meter. 100 meters in centimeter is 100 meter into 1 meter is 100 centimeters. So something of this sort. So pi into r square into 100 meters, which is 100 into 100 centimeters. So everything has been converted to centimeter. Your final sort of answer will be in centimeter cube. If you want to convert it to centimeter cube, you could have alternatively chosen to keep everything in meter cube. That is also fine. For which you would have needed to convert 7 millimeter to meters. You would need to convert this to meters. You already had 100 meters. You would not need anything to convert. This is something you wouldn't need. So yeah. Is this clear, Vinay? This will be your answer. If you were to simplify this, this will be 10 square will check out 100. This is 15400 centimeter cube. 15400 centimeter cube. And if you want a meter cube, just move away 6 decimal places to the right. So here, this is 2, this is 2, this is 2, 0. So 0.0154 meter cube has to be your answer. Since 1 centimeter is 1 by 100 of a meter. This is 4. Okay, cool. I hope this is clear. There are other good questions in this sheet, but I would want to know if you had any problems with question number 3. Any problems with question number 3? Okay, cool. No problems, I'm assuming. Okay, very good. Yes, Vinay, go ahead. You guys should use audio more if you want, It's quicker and it's more convenient. You want me to explain question 4? Okay. A sheet of paper 44 centimeter long is rolled into roll a long length to form a cylinder. What does that mean? It's exactly what we had discussed, Vinay. Okay, I've closed that board. What we had discussed, if you remember, was that you change a cylinder, you cut it, and you convert it to a sheet like this. So rolling along the length means this. This is the side being rolled. So 2 pi r becomes, where's my sheet? 2 pi r becomes 44. No, no, it's 44. If 44 is the length, 44 centimeter long, it says. Yeah. So 44 is my length without a shadow of doubt. This changes to 2 pi r. And of course, the height remains 20. I guess you can calculate it now. Pi r square h is the volume of the cylinder. Okay, cool. Excellent. Okay, then let's talk about a few other questions. I definitely want you to try these questions here. So I'll share my screen. I'm sharing my screen here. Why don't you try? Why don't you try question number 12, please? Please try question number 12 on the top right. Sorry. Please try question 12 on the top. Yeah, I'll get back to that. Yeah. Please try question 12. It's a fairly simple question. You have to calculate angle ACB. Yes, indeed. 50 is the right answer, guys. Okay, what about another question? Yeah, yes, 50 is the right answer. Good. Uh, what about simple questions? Nothing very difficult right now. What about question number 1? I hope it's visible. It's angle C here is 80. This is 80. Angle C is 80. Angle T is 30. And AC is a chord, clearly. It's not a tangent. It's not a diameter. It's a chord. I would also want you to try question number 4 after you tried 1. I hope you've tried 1. I've taken the screen away. Try question 4 is a good question. sorry, 4 is back. Try question 4 and question 5. Both are simple. Please try question 4 and question 5. Okay, done. Have you tried question 4 and 5? Any answers to question 4 or to question 5 or to question number 1? Five is yes, indeed. When 5 is 20, interested in the question, interested in the answer to question 4 and to question 1. We'll discuss if you guys have 1 is 1 is also 50. Yes, indeed. 1 is 50. Okay, let's discuss. Should anyone have a problem, I'll just if anyone has a problem, then we'll discuss 50. We'll discuss the questions. Any problem in question? Any problem in question 1? Okay, 1 uses the property of alternate segment theorem. How? This is my circle, this is the tangent, and this is the chord. Yeah, the chord is making 80 degree here with the tangent. Let me reshare the. Which means that angle ABC will also be 80 degrees. The angle here, is that how it looks like? Yeah. Angle ABC, this angle is also going to be 80. And since extending this, since TC, this is TC, this is A, this is B. Since TC is the tangent, and this angle is 30 degrees, it leaves this angle 80 degree. Angle B becomes the exterior angle in the triangle CTB, exterior angle of interior angle B. So if this is 30, the other angle C, this angle has to be 50. 30 plus 50 has to be equal to 80, and thus the remaining angle that you need to calculate ACB is from 180 degree from the straight line that this is. You can subtract 180 minus 80 is 80 minus 180 minus 80 is 100, minus 50 gives you angle ACB, which is 50 degrees. Okay, cool. Problems? Any problems with question 4? I will discuss in any case. Any problems with question 5 here? It's very simple. Question 5 is very simple. You need to use the property of cyclic quadrilaterals. Okay, I guess there's nobody is saying if there's any problem. Question number 4. Any problem with question 4? No. No, it is not. It is related to a property we had studied last time. It's a really good question. I will definitely discuss this when I don't worry. So I have this triangle, I guess ABC was it, and when I extend AB and AC, so on AB extended and uh, on AC extended, you draw a circle that touches all three. Yeah, you can draw a circle that touches all three. Now, what does that mean? Now, this if this point is D, let me call this point the point where the circle is touching BC. Let me call it E. Now, have a look at B, D, and E. This is B. This is point D here. Let's say this is point E. Can I not say for the circle BD and BE are tangents from the same point B? Aren't BD and BE tangents from the same external point B? Won't they be equal? Won't BD be equal to BE? Absolutely. Both tangents from the same external point. In the same way, okay, sorry. So let's take this to be F. E has already been taken. Let's take this to be F. So yeah, it doesn't change much. Let's take this to be F. This was point F. And this is point E. Similarly, if we were to look at a close-up of FCE, look at FCE here. This is C. You have F here, and the circle then touches E. Something of the sort. Now, isn't C again an external point, and CF and CE are tangents, so they'll be equal? Yes, they will be. CF will be equal to CE. Yeah. Now, how does that help? How does that count? Look at the bigger triangle as well. At the bigger picture, won't AD and AE also be equal? AD and AE are also tangents from the same external point A. So my tangent AD will be equal to AE. Will be equal to 15. So what can I do now about the perimeter? Let's have a look at what the perimeter of triangle ABC is going to look like. A perimeter of triangle ABC is going to be AB plus BC plus CA. Yeah. Now AB plus BC plus CA. Can I break? Let me just keep AB like this. Can I break BC into BF plus FC? And of course keep CA like this again. Now we've just seen that BF is equal to BD. Here, we've just seen here BF is equal to BD. So if I combine AB and BF and replace BF with BD, I get AB plus BD, which gives me AD. This is AD. And similarly, if I combine FC and FC, is here, FC is equal to CE. So if I replace FC with EC or CE and combine that with CA, I get AE. So my value finally will be area of perimeter. The value of the perimeter is AD plus AE, and since both are equal to 15, this will be equal to 30. So perimeter becomes equal to 30. Any doubts here, guys? Is this clear? Excellent, excellent then. Okay, really good. Uh, okay, you didn't have any problem with three. So let's end here. I do have a lot more questions for you, which I'll send through email.